Hi, this is Charlotte out here in El Sobrante, California, San Francisco Bay Area, and this week for Introduction to Music Production, I'll be doing a brief tutorial on mixing effects. So to get started, let's review a few wave properties, taking a look at this trombone waveform. We can see it has an amplitude, which is basically the magnitude of it. The difference between the maximum and the minimum there is called the dynamic range. Propagation refers to how a wave travels through space and time. And then finally, the timbre relates to kind of the color of the sound. And you see that jagged pattern there on the waveform. That's the result of the superposition of the waves for each of the harmonic frequencies produced by that instrument blending together. And that's how we get that jagged form. So keep this in mind about the various frequencies, because that's going to come into play here in a minute. Three categories of effects. The first is dynamic, the second is delay, and the third is filter. Dynamic effects relate to amplitude, so it's the compressor, limiter, expander, noise gates. Delay relates to propagation, reverb, phaser, flanger, and chorus. And filter relates to timbre, so high and low pass, band pass, and parametric and graphic equalizers. Starting with the dynamic effects, compressor and limiter. A compressor is going to decrease that dynamic range by attenuating the louder signals and boosting the quieter ones. So what you get is kind of more of these highs and lows here. After compression, it's kind of more squished together, so you see it has a broader band here in the middle. A limiter is going to keep the output level at or below a specific level, no matter what the input level is. So before we had kind of more of these peaks here, and here you can see they're kind of clipped off. For the expander and the gate, basically an expander is the opposite of a compressor. Compressor limited the dynamic range, or squished it together, and expander is going to increase that range. Okay? And one use of this is to create a noise gate, which is going to increase the dynamic range by lowering the noise floor, and then you can use this to remove background noise. Moving to the delay effects, which is basically for all of these, you have an original signal mixed with some kind of delayed copy of itself. The first is reverb, where you'd have an original signal mixed with a series of delayed copies of itself. And what's going on here is you're creating the effect of a space or of a room. If you're sitting in a room, you hear the original sound, and then you're also going to hear the reflections of that sound off of the wall. So that's sort of what this graph represents here, is you'd have original signals, and then you'd have like these other sounds bouncing off the wall back to your ear, and then they sort of fade out, eventually, and that's why you have that taper down there at the end as it sort of fades out. A flanger is where you're going to take the signal and mix it with a slightly delayed copy of itself. And here in a flanger, this delay is going to be independent of the frequency and can be modulated. Okay? Now you can compare this with a chorus and a phaser. A chorus is like a flanger mixing with that delayed signal, but it's a longer delay, so the pitch is affected. So this you kind of get sort of, sounding like different people are singing together or something like that. A phaser is like the flanger, but it delays it a little bit differently. Here it's going to put one signal part through an all-pass filter and then invert it to delay the signal. But it's not going to happen all at the same time. Different frequencies are going to have different delays. Okay, so you get kind of a slightly different effect from the flanger. Moving on to the filter effects. The first one are passes. So for the high and the low pass, basically what you're doing, going back to those frequencies we talked about at the beginning, is if you have a low pass filter, you're going to allow these frequencies through, but you're going to cut these off above a certain point. In a high pass filter, you're going to allow these frequencies through, but you're going to cut off these low ones at this point. If you put those two together, a low and a high, you get a band pass filter. So you're letting this band of frequencies pass through. A notch filter is the opposite of that. We are letting these frequencies pass and these, but you're not letting these pass through in this notch. And then finally, we have the equalizers. The first type is the parametric equalizer, which is going to control the level and the center, which is the primary frequency around which you're equalizing, and then the bandwidth and the range of frequencies. A little bit different equalizer is the graphic equalizer, which is basically just a series of variable filters for boosting or attenuating certain bands or frequencies. So thanks for taking the time to review my presentation, and I hope it was useful. Thank you.